Good morning, students. Myself, Vijay Shankar from EC Department, Chibral Engineering College. Today, we are going to discuss about the Z transforms properties. We already discussed the Z transform introduction and some examples of the Z transform. Again, we go through that examples and the Z transform concept before going to discuss about the Z transform properties. Okay. So Z transform is a fundamental difference between the continuous and the discrete time signals. We already know. The continuous time signal is x of t, and discrete time signal represented as x of n. And discrete time signal represent using complex exponential and sinusoidal components. The discrete time signals represent using the complex exponential and also the sinusoidal components. So here I wrote the reference with the unit 1. In the unit 1, we already discussed about what is the difference between the continuous and the discrete time signal, and how we can represent the discrete time signal in the complex exponential and the sinusoidal components. See the property here, periodicity properties of the discrete time complex functions. Periodicity properties of discrete time complex function. See, continuous time function is x of t is equal to, this is a condition you have to satisfy. The given signal is a periodicity, or the periodic means x of t is equal to x of t plus capital T, where t is fundamental period. The t is a period of that. Even you can add the t for the given signal, it is equal to the same. At equal interval of time, it is repeated the signal with the period of t. Now coming to the discrete time signal, the x of n is equal to, since we can represent discrete time signal is x of n is equal to x of n plus capital N. Okay, where n is a period here. Where n is period. Okay. The only difference is representing of t as continuous, n is continuous, and the summation is using the discrete time signals. Coming to here, the complex functions. Complex functions. A discrete time complex exponential is periodic if it repeats after certain n number of samples. Periodicity means only if it repeats after. Suppose the waveform is look like from 0 to t like this. Again, it is repeated from 0 to 2t and 0 to 2, 3t. For every t samples, the signal is repeats. The signal is repeats. We can call it as a periodic property, or the periodicity, or the property here, periodicity signal x of t. Now we are taking here the exponential signal. Consider the x of n is equal to e power j omega naught n. Now I am changing n as n plus capital N. So x of n plus capital N is equal to e power j omega naught n plus capital N. N plus capital N here. Now you can rewrite this exponential value, the base, the power you are already added here. You can split these two parts. e power j omega naught small n, e power j omega naught capital N. For periodicity, you have to satisfy the condition x of n is equal to x of n plus n. Okay. Now, what is a e power j omega naught n? E power j omega naught n. So e power j omega naught n, capital N, my dear students, here, capital N. You can write in the cosine function, the sine function here, cos omega naught n plus j sine omega naught n. Okay. And cos omega naught n plus j sine omega naught n in the full cycle is a e power j theta plus equal to cos theta plus j sine theta. For periodicity, e power j omega naught capital N is always a 1, my dear students, because omega naught n is equal to omega naught means 2 pi f naught, the 2 pi f naught into capital N. So for whatever the multiplication factor is there for the 2 pi, cos 2 pi is a 1 and the sine 2 pi is a 0 always. Okay, omega naught n here, it is multiplied with the cos 2 pi, 4 pi, and the 6 pi and 8 pi. The k is an integer here, the k value. Okay, my dear students. So in this, the e power j omega naught is not capital N is equal to 1 always. 1 always, because of in the Euler's identity, you can write it as cos omega naught n plus j sine omega naught n. And the omega naught is a 2 pi f naught in the capital N. Definitely the capital N is an integer. The frequency also it is a here. So it is multiplied with the 2 pi into the k. Let us, I am assuming this is a k value. 2 pi k, cos 2 pi k plus j sine 2 pi k. Cos 2 pi, what is a cos 2 pi? 1. And what is a sine 2 pi? Is a 0. So always e power j omega naught capital N. The capital N is an integer here. It's always a 0. Not the 0, it is always is a 1. Sorry. So from that, you can write the fundamental period omega naught n is equal to, we got it as 2 pi into k. Omega naught n is equal to 2 pi into k. The k is an integer, and omega naught by 2 pi, you can write here, is equal to k by the n. So instead of the omega naught n, if I take the 2 pi k, e power j omega naught n is always a 1 for periodicity. Now to find the fundamental period here, omega naught by the cross multiply, you can do it here, the omega naught by 2 pi and the k by the n. What is the omega naught? 2 pi f naught, or f we can write as the 2 pi is equal to k by n. And the 2 pi get cancelled. The f is equal to k by periodic. What is the fundamental period here? The omega naught by the 2 pi is equal to k by n. That is a rational. Is a fundamental period. Or to find the fundamental period, n is equal to k by f. K by f. Where k is, you can assume, where k you can assume a smallest multiplier to get the fundamental period as an integer. Understood, my students? Okay. Next. So Z transform concept here. The last class, yesterday's class, we already discussed this one. Z transform concept, the definition of Z transform here. The Z transform of x of n is denoted by x of z and defined as x of z is equal to sum of n is equal to minus infinite to infinite x of n z power minus n, where z is a complex variable. X of n and the x of z is called Z transform pairs, represented as x of n, the Z transform x of z. The purpose of learning the Z transform is to analyze discrete time signals. Remember here, to analyze discrete time signals. Fourier transform and the Laplace transformation is analyzing of the continuous time signals. Okay, the purpose of learning the Z transform is to analyze the discrete time signals and the systems, digital filters design, and for synthesis of digital filters or systems. So purpose of learning the Z transform is to analyze the digital signals and systems, digital filters design, and for synthesis of digital filters or the systems. Okay. For any input of the sequence, the Z transform is complex. It has a real and the imaginary part. The x of n you can give into the Z transform, converting it to the frequency domain function x of z, having real and the imaginary parts. Why you're saying it is a real and imaginary part? The z is where the z is a complex variable here. Complex means having the real part and the imaginary part. Okay. Now, the difference between the distinguish between the Laplace and the Fourier and the Z transform. Okay, there is a interrelated in the definition of the Laplace, the Fourier, and the Z transform. Okay, the Laplace having the relation with the Fourier transform means definitely there is a Laplace and the Z transform also there is a interrelated. Fourier transform also it is a interrelated. Z transform is given x of z is sum of n is equal to minus infinite to infinite. Sum. Why you wrote this sum here means we are analyzing the digital signals x of n z power minus n, where the z is defined as z is equal to r j omega. R is a magnitude here and omega is an angle. Okay, omega is an angle, or you can write it as a theta also. Nothing in confusion though. And z is equal to r e power j omega. You can substitute in the definition of the Z transform here. Sum of n is equal to minus infinite to infinite x of n r into e power j omega minus n. The z I replace with the e power j omega. So sum of n is equal to minus infinite to infinite x of n. Write this r of minus n as a one signal totally e power j omega n minus j omega. And this is related to the Fourier transformation equation only. So what is the Fourier transformation equation? X of t into e power minus j omega t, and the dt because of in the e power minus j omega n is a discrete and t is a continuous time signal. So Fourier transform is given by the x of omega is equal to sum of n is equal to minus infinite to infinite x of n e power j omega n. Comparing the x of omega with x of z, comparing with the x of omega with x of z, we find that x of z indicates a Fourier transform of x of n r power minus n. X of n r power minus n. So the Fourier transform also represented here the sum, because the signal I take is a discrete time signal. Here it is a continuous. You can apply the integral whenever you can take the discrete time signal, you can apply the sum of in the Fourier transform equation also. X of omega is equal to, this x of omega is equal to, or now instead of x of omega, I'm writing the x of omega here, the sum of n is equal to minus infinite to infinite instead of the integral x of t. Now I'm taking the continuous x of t as discrete time signal x of n, and e power minus j, the omega here I wrote omega n value. Okay, this is a Fourier transformation equation for the discrete. Now the comparing these two equations, the x of z indicates the Fourier transform of x of n r power minus n. Okay, it's a relation between the Fourier transformation and the z transform. And we already have a relation between the Fourier transform and the Laplace transform also. And you see that. You see. So x of z, where the z is equal to e power j omega, it becomes of x of omega. So the transform is converted into the Fourier transform by replacing the z is equal to e power j omega, and the magnitude is equal to 1. You see here, it evaluated on the unit circle, the magnitude of z is always a 1 here. Then only there is a relation we have, the x of z, where the z is representing as e power j omega, it is equal to the x of omega. The Fourier transform and the z transform relation between. Now the Laplace transform and the z transform. The Laplace transform of the input signal, according to the definition of the Laplace transformation, x of s is equal to integral 0 to infinite. I'm taking only the unilateral z transformation, Laplace transformation, 0 to infinite x of t power minus st dt. And substituting s is equal to sigma plus j omega in the above equation, x of s is equal to integral minus infinite to infinite. You can take these also minus infinite to infinite minus. It's a minus infinite bidirectional, minus infinite to infinite, x of t e power s. What is the s here? Sigma plus j omega into t, where sigma is a real part and omega is an imaginary coefficients. But the definition of Fourier transform of x of t, the x of j omega, x of omega or x of j omega, you can write here. X of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. And in this, comparing the equations of the 2 and 3, we can say that by replacing sigma is equal to 0, and sigma is equal to 0 here, e power 0 value is a 1. So the Laplace transformation is converted into the Fourier transformation. Okay, in the Laplace transformation, x of s is equal to j omega, s is equal to j omega, it is equal to the Fourier transformation. Is equal to the Fourier transformation. And when z is equal to e power j omega, it is equal to the Fourier transformation. The transform is related to the Fourier transformation. Laplace transformation is related to the Fourier transformation. By replacing z with the e power j omega, it is converted to the Fourier transform. And in the Laplace transformation, substitute s is equal to j omega. The Laplace transform is converted into the Fourier transformation. Okay. Now, these also, the last class we discussed, it is a very important, I told, the region of convergence in Z transform. The region of convergence in Z transform. There's some points we have. Since the Z transform is infinite power series, infinite means the sum of n is equal to minus infinite to infinite. Since the Z transform is an infinite power series, It exists only for those values of Z for which the series is convergence. Since the Z transform is an infinite power series, it exists only because it is a Z is greater than A or Z is less than A, or if A1 less than the Z and less than the A2. Following my student, Z is greater than A. For these values only the Z transform can exist. And Z is less than A, means in the left hand side values only it exists X of Z. If having the two region of convergence A1 and A2 in between, greater than the A1 and less than the A2, in between of these two values only the Z is exists only for those values of Z for which the series is convergence. The series is convergence, even if it is a finite minus infinite to infinite, it depends upon the region of convergence. Either it is a positive direction towards a positive and is related towards the negative values, and here it towards a positive and towards a negative, in between only we can take here the region of convergence. For those values of Z, the series is convergence. Got it? And second point saying that the region of convergence X of Z is a set of all values of Z. Set of all values of Z for which X of Z you have to get the finite value only by substituting all the values of Z when the region of convergence having either is a greater than or the less than or in between. For those values only the function is exists, and that function is equal to the finite value for all the values of the Z, the region of convergence. Not it is equal to the infinite, my dear students. You see, already we discussed the region of convergence is a ring or disk in the Z plane centered at the origin. The region of convergence cannot contain any poles. If X of n is a finite duration causal sequence, then ROC is entire the Z plane. If X of n is a finite duration anti-clockwise sequence, the ROC is entire Z plane except Z is equal to infinite. If X of n is a finite duration, the two-sided sequence, the causal sequence means the positive direction, my dear students. The ROC is entire Z plane at Z is equal to 0. Anti-causal means when H of n is equal to 0, H of n is equal to 0, n less than the 0. Anti-causal means the reverse operation. The two-sided, the X of n is a finite duration, the two-sided sequence, then the ROC is entire the Z plane, except Z is equal to 0 and Z is equal to infinite. For these two values only, it does not exist. For the remaining all values, it exists when it is two-sided sequence. But here, the anti-causal sequence, except the Z is equal to infinite, X of n is a finite duration, the remaining all the values, the function X of Z exists. Okay. If X of n is infinite duration, the two-sided sequence, the ROC will consists of a ring in Z plane bounded on interior and exterior by a pole cannot containing any poles. Pole not containing any poles. Suppose I already discussed that the mapping of the S plane and the Z plane. Stability system is in the left hand side, and it is a mapping in the Z plane. Mapping in the Z plane is interior. So the S plane here, Z plane always on the unit circle. Left hand side values means Z is less than the A, is interior of the circle, and the outside the circle is positive values, the S plane, and if there is any imaginary values are there in the S plane, it's not on the circle. Is the mapping here. Okay, interior, exterior, and on the circle. That only they are explaining here. If x of n is an infinite duration, two-sided sequences, the ROC will consist of a ring in Z plane bounded on interior and exterior by a pole not containing any poles. Following. And seventh, the ROC of an linear time invariant system is stable system contains unit circle. The ROC must be connected the region. Okay, the ROC must be connected the region. That is, the region is if Z is less than A, the left hand side, the region of convergence here towards the left hand side, and this is towards the right hand side. Got it? And finite duration, the right hand sided causal sequence. Right hand sided means definitely that is a causal only. Left hand side is there, the values means that is an anti-causal. Right and the left means opposite values. Right side values is a causal means if there is a left hand side the values is there, that you can call it as an anti-causal signal. So let x of n is with the finite duration, the signal with n samples, signal with n samples defined in the range of 0 less than n less than or equal to n minus 1. So I'll have x of n as x of 0, x of 1, x of 2, and so on, the x of n minus 1. Substitute these values in the x of z definition in the z transformation. We have only the 0 to n minus 1. So take the summation is from 0 to n minus 1, x of n z power minus e. So expand this 0 to n minus 1 values. X of 0, z power 0 is 1. X of 1, z power minus 1 is, we'll get in the denominator because it's a negative powers of z. X of 2 by z square and x of 3 by z cube and so on. X of n minus 1, z power n minus 1. So when this see, when z is equal to 0, you can substitute because in the denominator 1 by 0 is infinite. Except z is equal to 0, for remaining all the values, it can exist because to get the finite value. When the z is equal to 0, all the terms except the first term become infinite. So except the first term, and this term is infinite, and this term is infinite, and this term is also the infinite. So infinite plus anything is becomes of infinite. It is not exist. X of z is not exist for the values of value of z is equal to 0. Hence, x of z exists for all the values of z except z is equal to 0. This is a third point, my students. X of n is a finite duration. Is a finite means 0 to n minus 1 here. Causal sequence, nothing but is a right-sided. Then the ROC is entire z plane except z is equal to 0 here. Entire z plane means all the values of z, the function x of z is exists. But when the z is equal to 0, the function x of z becomes infinite. So it is not exist, but z is equal to 0, and remaining all the values of z, it is exist, and we'll get the finite duration. Suppose if you can find, substitute the 1 here, x of n by 1, x of 2 by 1 square, and so on. Adding of all the terms here, you'll get the finite only. Okay, not it is an infinite. The third property here, there is a proof. Except z is equal to 0, the x of z exists for all the values of z. Therefore, ROC for finite duration, right-sided is entire z plane except z is equal to 0. Right-sided means nothing but here a causal sequence. Understood, my students? Next case. Finite duration, the left-sided anti-causal signal, left-sided. So now I'm taking the left-sided means x of 0, x of -1, -2, and so on, the minus n minus 1. Now see, in the definition, I take from the minus n minus of n minus 1 to the 0, left-hand side. So look like this is a right-hand sided, mu of t. Left-hand sided means mu of minus t, minus 1. So 0 to infinite here, and here is a minus infinite to 0. But I'm not taking the infinite duration, finite duration only. That finite duration here it is n minus 1 as a plus, and here I'm taking the minus of n minus 1 because these are all the minus values. So n is equal to minus of n minus 1 to the 0, x of n z power minus n. Now expand with these values, x of minus of n minus 1, z power minus into minus is the plus, n minus 1, and so on. X of minus 1, z power minus of minus 1 is a z power 1 here. And x of minus 2 is z power minus of minus 2 z square. And here the x of 0, z power 0. The value is 1. Now see here, if I am substituting z is equal to infinite, because it is a multiplication factor here, z is equal to infinite, this value is infinite and this value is also infinite and this value is also infinite. Infinite plus anything is a value is infinite. So except z is equal to infinite, for all the values of z, including the z is equal to 0 also here, including the z is equal to 0, z is equal to 0, z is equal to 0 means the value is a 0. 0 is a finite only, not is a infinite. When z is equal to infinite, all the terms except the last term, is this one, become infinite because z is coefficient is multiplied for all the values. Hence, the x of z exists for all the values of z except z is equal to infinite. So when I am taking the z is equal to infinite, in this from the first to the but one values, all the values is infinite except the last one here. What is the last one here? X of 0. So hence, the x of z exists for all the values of z except z is equal to infinite. Except z is equal to infinite. Therefore, ROC of x of z is entire z plane except z is equal to infinite. Okay. See here. Fourth one. The case 2, what we prove here now, the x of n is a finite duration. Finite means minus of n minus 1 to the 0. It is an anti-causal because causal means right-hand sided. Anti-causal means left-hand sided sequence. Then the ROC is entire z plane except z is equal to infinite. Except z is equal to infinite, for the remaining all values is exists. Got it, my dear students? Anti-causal except z is equal to infinite. Causal except z is equal to 0. And third case here, non-causal signal. Non-causal. A finite duration, the two-sided non-causal signal. Two-sided I am taking. Left side is anti-causal, right side is a causal. And two-sided is a non-causal. So let us see. Let x of n be a finite duration. The signal with n samples are defined in the range of minus m to m, minus m to m. Well, negative values I am taking and the positive values also taking. Okay. So where the m is n minus 1 by 2, you can take here, where m is equal to n minus 1 by 2. So the x of n range, I am taking x of minus m, minus 2, minus 1, 0, and 1, 2, and so on up to the m. So it is a duration of minus m to the m, minus m to the m, my dear students. The transform of x of n is the definition according to that x of z is equal to sum of n is equal to minus m to m, x of n z power minus n. Now expand the value here. X of minus m z power m plus up to so on x of minus 2 z square, x of minus 1 z, x of 0, and positive values here, x of 1 z power 1, x of 2 z power minus 2, and so on, x of m z power minus m. Okay. See, up to before the x of 0, the z is a positive power z. After the x of 0, the z is a negative powers of z. So when I am substituting z is equal to 0 in this total equation, z is equal to 0 means negative powers of z becomes infinite. Z power minus 1 is equal to infinite. So all the values e power minus. And z is equal to infinite, the positive powers of z is infinite. So except z is equal to 0 and z is equal to infinite, the remaining all values is exist here. Okay, up to the values of, see here the x of minus 1, z power m, z power square, and x power minus 1. For these values, z is equal to infinite is not exist. And for these values, z is equal to 0, you can substitute here. The function becomes infinite here. And here, the function becomes infinite. So except z is equal to infinite and z is equal to 0 in this equation, for remaining all values is exist. So z is equal to 0, the terms with the negative powers of z attaining infinity. And z is equal to infinite, the terms with the positive powers z attains the infinity. Hence, x of z converges for all the values of z except z is equal to 0 to infinite. Not the 0 to my student, sorry. Z, except at z is equal to 0 and z is equal to infinite. Therefore, the ROC is entire z plane except the two values. But in the left hand side, except z is equal to infinite. Right hand side, except z is equal to 0. But both sided means except z is equal to 0 and also the z is equal to infinite. The system is not exist. The function is not exist. For remaining all values is exist. Okay. That is one of the ROs here. Fifth one. Third one is right hand sided is a causal sequence. Fourth one is left hand sided is an anti-causal sequence. And fifth one here, if x of n is a finite duration, the two-sided, then the ROC is entire z plane except z is equal to 0 and z is equal to infinite. Got it, my dear students? Causal, anti-causal, and non-causal. Okay. Non-causal means if any value, any one value is present in the left-hand side, that is a non-causal. Even there is a values is there in the right-hand side. All the values in the right-hand side means causal. All the values is there in the left-hand side means anti-causal. And there is a values in the left-hand side and there is a values in the right-hand side means is a non-causal signal. Got it, my dear students? Next, we already discussed the causal, anti-causal, and the non-causal. Now, another one is there. So, infinite duration now. Until now, we discussed about the finite duration only. For the finite duration, the causal left-hand side. For a finite duration, anti-causal right-hand sided. And for a finite duration, non-causal except z is equal to 0 and z is equal to infinite. The remaining entire value is, entire z plane is exists for convergence. Now I am taking the fourth case, infinite duration, the right-sided signal, nothing but causal. So x of n is equal to, let x of n is equal to r1 power n, r1 power n, x of z is equal to sum of n is equal to minus infinite, x of n z power minus n, and sum of n is equal to 0 to infinite. And now I take the r1 power n z power minus n. Replace, not the replace, take the power in the r1 z power minus 1 whole power n. It is in the form of, I already told the sum of n is equal to n1 to n2 a power n value. What is the a power n? A power n1, 0. So 1 in the numerator, and in the denominator 1 minus r1 z power minus 1. Using this relation, my dear students, sum of n is equal to n1 to n2 a power n. Once again, I am saying this, we already know a power n1 minus a power n2 plus 1 by 1 minus a, and here the one condition is there, n2 is greater than the n1 and a is less than the 1. What is the n1 here? 0. Sum of n is equal to 0, n1 here. What is the n2? Infinite. And what is the a here? R into z power minus 1 whole power n. R1, they are writing the R1. So with this, you can substitute a as R1 z power minus 1. What is the n1? 0. R1 z power minus 1. What is the n2 here? Infinite, plus 1. Whole divided by 1 minus a. A is nothing but R1 z power minus 1. So infinite plus 1 is nothing but infinite. Anything power 0 is 1. Anything power infinite is a 0. And whole divided by 1 minus R1 z power minus 1. That is equal to 1 by 1 minus R1 z power minus 1. Here one condition is that a is less than 1. What is the a? R1 z power minus 1. R1 z power minus 1 is less than 1. So R1 by z is less than 1. So R1 is less than z, or z is greater than R1. Okay, z is greater than R1. Remember that. That is ROC. Z is greater than 1, R1. For all the values of z is greater than R1 only, the function is exist. Got it, my dear students? So z is greater than R1 represent a circle of radius R1 in the z plane. See the circle here with the radius of R1. Now the x of z converges for all points external of the circle, because z is greater than R1. External is only the shaded area is outside the circle here. Outside the circle, because it is z is greater than R1 with the radius of R1. The outside the circle is a region of convergence. This is the total region of convergence. Exterior. So for infinite duration, the right-sided causal sequence is an exterior. Exterior, simply saying. Okay. Anti-causal means definitely is the interior only. Anti-causal means definitely that is a interior signal. Got it, my dear students? Now I am taking the x of n is equal to R2 power n, substituting the definition of the Z transformation. Let's simplify here. 0 to infinite. Here the infinite to 0 I am taking. Infinite to 0. Why it is a infinite to 0? Minus infinite to infinite is becomes of a minus infinite to 0. When I am changing these negative values here, x to r2 power n, z power minus n. So 0 to infinite, changing the powers here. So negative values is there in the summation. You change the positive values and keep here it is a negative powers. So r2 power minus 1 and the z. 0 to infinity a power n. The same thing what we have here. Sum of n is equal to 0 to infinite cn is equal to 1 by c. Or what I told the n1 to n2. Use the same equation also. So 1 by 1 minus r2 power minus 1 z. So 1 by 1 minus r2 power minus 1 z. Now to satisfy the condition is r2 power minus 1 z is less than the 1. Or z by r2 is less than the 1. Or z is less than r2. So draw a circle here. Draw a circle with the radius of r2 and z is less than. Less than means inside the circle, ROC, the shaded area. The condition satisfies the z is less than the r2. Got it, my dear students? So anti-causal is interior. The left-hand sided, the infinite duration, left-sided is an anti-causal signal that is shown in the interior of the circle. The term R2 represents a pole of radius R2 in Z plane. X of Z converges of all the points internal of the circle of the radius R2 in the Z plane. Therefore, ROC of X of Z is interior of the circle of radius R2. Interior of the circle of radius R2. And same infinite duration if I am taking the two-sided anti-causal signal, two-sided. So one term will get greater than A and one term is less than A. So which is greater than A? R1. Okay, R1 is interior inner circle and R2 is a outermost circle. So in between there is a shaded area here. Z is less than the R2 and Z is greater than the R1. Okay, overlapping, where it is a overlapping is there, that only we can take it as a region of convergence. So two-sided. So in between of R1 and R2, therefore the ROC is a region between the two circles of the radius R1 and R2. Got it, my dear students? These are the finite durations ROC. The third point we already discussed how it is a finite duration is an entire Z plane except Z is equal to 0. And fourth point we discussed is a finite duration, the anti-causal sequence, the ROC is entire Z plane except Z is equal to infinite. And the two-sided when the finite duration is except Z is equal to 0 and Z is equal to infinite. And sixth point now we discussed if X of n is an infinite duration, the two-sided sequence, the ROC will consists of a ring in Z plane bounded as interior anti-causal, exterior causal by a pole not containing any poles. Got it, my dear students? And ROC of a linear time invariant stable system contains a unit circle. Stable system means a left-sided sequence is inside the circle, interior, nothing but is anti-causal. The anti-causal is a stable system, simply we can say. ROC of the linear time stable system contains a unit circle. Then ROC must be contain the region, must be connected to the region. ROC is always connected to the region. So very, very important properties, my dear students. The properties of ROCs and the proofs we have. The case 1, finite duration, Case 2, finite duration with left-sided. Case 3, finite duration with two-sided. Case 4, infinite duration with right-sided. And case 5, the infinite duration, the left-sided. And case 6, infinite duration, two-sided sequences. Okay, now coming to the properties of Z transform. Properties of Z transform, my dear students. Until now, we discussed about the properties of a region of convergence in the Z transformation. A region of convergence. Now the actual properties of the Z transformation. These are the properties already we discussed the names in the Fourier transform, Laplace transform, and the Fourier series also. What are the proper names? It is a linearity property, time shift property, frequency shift property, differentiation property, integral property, Parseval's theorem, and convolution modulation. Okay, so a few of the properties, the name is the same as in the Z transformation also. The first property, linearity property. The first property is a linearity property, what we already discussed in the Fourier transform, Fourier series. There is a Laplace linearity property is there. Fourier transformation, we have linearity property is there. And the Laplace transformation also, we have the linearity property, my dear students. And with the Z transformation also, we have linearity property with the same, but the definition is different. States that the Z transform of the linear weighted combination of discrete time signals is equal to similar linear weighted combination of Z transform of individual discrete time signals. Individual means x1 of Z and x2 of Z. When combining the two signals, a linear weighted combination of discrete time signals is equal to similar to linear weighted combination of Z transformation of individual discrete time signals. Let Z transformation of x1 of n is x1 of Z and Z transformation of x2 of n is x2 of Z. Then by linearity property, a1 x1 of n plus a2 x2 of n. Okay, the previous linearity property in the Laplace Laplace Fourier transform and the Fourier series. Here we are using the x1 of t and x2 of t because it is a for continuous time signals, but here it is a discrete time signals. Z transform is analysis for the discrete time signals. So Z transform of a1 x1 of n plus a2 x2 of n is equal to a1 x1 of Z, a2 x2 of Z, where a1 and a2 are constants. And substitute here the Z transform definition. X1 of Z is Z transform of x1 of n. The sum of n is equal to minus infinite x1 of n Z power minus 1. And x2 of Z is the transform of the signal x2 of n. In the definition, x2 of n Z power minus n. Now I am combining the two signals. A linear weighted combination of discrete time signals a1 x1 of n plus a2 x2 of n as a combined signal. Substitute in the Z transformation definition, sum of n is equal to minus infinite a1 x1 of n plus a2 x2 of n Z power minus n. Multiply the Z power minus n for these two signals, two terms here, a1 x1 of n Z power minus 1, a2 x2 of n Z power minus n. And split the two parts with the summation, sum of n is equal to minus infinite a1 x1 of n Z power minus n plus sum of n is equal to minus infinite a2 x2 of n Z power minus n. Okay. Check the a1 in the outside. Sum of n is equal to minus infinite x1 of n minus Z power minus n. As you see here, sum of n is equal to minus infinite x1 of n Z power minus n as x of Z. Substitute here. Another one is the sum of n is equal to minus infinite to infinite x2 of n z power minus n x2 of z. Okay. As it proves the linearity property of Z transform as linear weighted combination of discrete time two signals is equal to similar linear weighted combination of Z transform of individual discrete time signals. Individual discrete time signals. Okay. Is there any confusion, my dear students? Similar with the Fourier series, Fourier transform. Fourier series is x of k, means x1 of k plus x2 of k into a1 and a2. And coming to the Fourier transformation, a1 x1 of omega plus a2 x2 of omega. Coming to the Laplace transformation, a2 x1 of s, not the a2, a1, and a2 x2 of s. These are all we'll get for continuous time signals a1 x1 of t plus a2 x2 of t. Okay, this is for Fourier series, and this is for Fourier transform, and this is for Laplace transform for continuous time signals. But in the Z transformation is a discrete for the digital values analysis of the discrete time signals. So now it becomes of x1 of en plus a2 x2 of en. So discrete time signals. What is the Z transformation now? The a1 x1 of z plus a2 x2 of z. Procedure is the same. Only you can substitute the signal what we are combining signal, the time domain, and you can simplify that to get the Fourier series x of k, Fourier transformation x of omega, Fourier Laplace transformation of x of es, and Z transformation is x of z. Got it, my dear students? Now the shifting property. Shifting done in the time domain. Time domain means here the x of n, a discrete time. The shifting property of Z transform. The shifting property of Z transform states that the Z transform of a shifted signal shifted by m units of time is obtained by multiplying z power m to the Z transform of unshifted signal. Okay, I'm taking the x of n minus m number of samples is shifted in the time domain signal. In the frequency domain signal, x of z is multiplied with z power m. Z power m. Minus m is for x of n minus 1, and it is a x of n plus m, that is a z power m. Okay, both are, it is a shifting one. Minus of minus m this one, and this is a minus of plus m. But positive values of m towards the right side for this one, and these are towards the left side. Advanced signal and the delay signal. Got it? Proof here. The definition of the transform, x of n minus 1, x of n minus m, you can substitute. Let n minus m is equal to p, n is equal to p plus m. Even you can changing the values of n to p. Infinite is minus infinite only, the infinite and infinite only. There is no change of limitations. Sum of p is equal to minus infinite to infinite. X of n minus m is a p, and n is a p plus m. And x of p, you can write this as two parts, z power minus p and z power minus m. So see here, this is again the definition of z transform only. The sum of z power minus m into sum of p is equal to minus infinite to infinite, x of p z power minus p is x of z. For Here it is for delay signals. Now I'm taking the advanced signals x of n plus m, the minus here, and z power n minus m of n is equal to minus infinite to infinite. X of n plus m is z power minus n. Substitute n plus m is a p, and it becomes of p minus m. N plus m is equal to p, and n is equal to p minus m. Okay, so n is p minus m and n plus m is a p. Again, you can simplify this z power m into the definition of the z transformation, z power m into x of z. So either for negative values towards, you can shift towards the left hand side. Z power m is multiplied for the x of z, and shifted towards the right side means z power minus m is multiplied for the x of z. Okay, and the one-sided z transformation is there. One-sided z transformation, the shifting towards the right side or towards the left side. Both are one-sided only. Either you can shift towards the left side means that is a one-sided. Towards the right side means that is also one-sided. X of n minus 1, z power minus m x of z. X of n plus 1, z power x of 1. Both are in the one-sided. Okay. Whenever if you could take two-sided means two-sided, then only there is a left side and the right side will get. Got it, my dear students? Okay. The remaining we can discuss in the next class. So any doubt, my dear students? Any doubt is there? Okay. Thank you.